everyone, welcome to Ganit Academy. In this video we will be studying about the division of integers. You have already studied about the division of whole numbers, right? So similarly we will be studying about the division, that is in case of integers. So division of integers, so we will consider a divided by b, a divided by b. So we can also write like this, right? Here whatever you are going to get, that will be called as quotient, and if there is something which is here, that is a remainder. This is divisor and this is dividend, right? So you know about these terms: divisor, dividend, quotient and remainder. So here a divided by b. So here a can be a positive integer, it can be a negative integer. B can be a positive integer, it can be a negative integer. But normally b will not be equal to 0, because a by 0, that is something undefined, or we can also consider that as infinity. Okay, infinity. Or you can write undefined. So normally b should not be equal to 0 when we are dividing. So first let me consider 5 divided by 2. 5 divided by 2, this gives 2.5. But that is, no, that is not an integer, right? 2.5 is not an integer. So 5 by 2, this is a rational number. So this is also not an integer. So not an integer. Next. So from this first example, I can conclude that division, okay, division, it does not satisfy closure property. It does not satisfy closure property. Or we can say integers are not closed under division. Okay, so that is the first point that we get to know from the first example, 5 by 2. So integers are not closed under division. Okay, so this is about the closure property. Next, if I take 6 divided by 2, that will give you 3. So yes, 3 is an integer. 3 is an integer. This is a positive one. This is positive. This is also positive. So we can say that the signing conventions, this follows the multiplication rule. Okay, multiplication rule. And one thing you must remember, that division is nothing but it is the inverse of multiplication. Inverse of multiplication. For example, I can consider 5 into 2 is equal to 10, right? 5 into 2, that is equal to 10. If I bring this 2 to the right hand side, instead of multiplication, it becomes division in this case. So 5 is equal to 10 divided by 2. And yes, 10 divided by 2 is 5. So we can say division is nothing but it is the inverse of multiplication. So we can follow the same rules. So in case of multiplication, we had same signs, it was plus. Different signs, we had minus. So same thing applies to division as well. For example, plus 10 divided by minus 2. So plus and minus, it is minus. Divide these as whole numbers, that is 10 divided by 2, it gives you 5. Place the sign like this, plus into, okay, plus into minus gives minus, so place the minus here. Okay, or if I take to the right hand side, this becomes minus 5 into minus 2, and this is very well known. Minus into minus is plus, 5 into 2 is 10. Okay. Next is minus 10 divided by minus 2. And when we had same signs, it was plus. So here also it is plus. 10 divided by 2 is 5. Okay. This is. And next I will consider negative integer minus 10, this is divided by plus 2. So minus plus, it is minus, 10 divided by 2 is 5. Okay, so you can also verify this by cross multiplying. Cross multiplying is taking this to the right hand side, it becomes multiplication. Division becomes multiplication. Okay, so what you can write? Everywhere I got 5, 5, 5, right? So a divided by b minus a divided by b, that is equal to a divided by minus b. Okay, provided b is not equal to 0. b is not equal to 0. So minus a divided by b, that is equal to a divided by minus b, or a by b, that is equal to minus a divided by minus b. Okay, b is not equal to 0. So this is one case. So when we consider the closure property, so we have already seen that integers are not closed under division, because suppose a and b are integers, a divided b need not be an integer. Need not be an integer. Okay, example 5 and 2. 5 divided by 2 is not an integer. Next is commutative property. So is a by b equal to b by a? So let us check. 6 divided by 2 is equal to 2 divided by 6. Is that so? 6 divided by 2 is 3, but 2 divided by 6 is not 3. So that is also wrong. So commutative property, it does not hold good for the division of integers. Next comes associative property. Associative property, a divided by b divided by c, that is not equal to a divided by b divided by c. Obviously this will not be equal, because commutative property only does not hold good for the division of integers. Obviously associative property will not hold good for the division of integers. Next, some important points is a divided by 1, but it is not equal to 1 divided by a. But a divided by 1, that is equal to the number itself. Okay, it is equal to the number itself. 0 divided by anything, 0 divided by anything, that will give you 0. It is nothing but a into 0 is equal to 0. We have already studied this. So 0 divided by a is equal to 0. A divided by minus 1, that is equal to minus a. Okay, so these are some other important points.